Alrighty, how's it going, everybody? Welcome to the first set of online class notes where we'll be discussing a lot of different topics, okay, that's going to really set the foundation for this year. So let's go ahead and get started. So the first thing we have to be comfortable with is number sense, okay? We have to be comfortable with different types of numbers that we'll be experiencing when graphing a lot of these future parent functions. The first thing is numeral numbers. Now, a lot of us know them to be whole numbers, okay? And so we could say that these are whole numbers. And when I mean whole numbers, I mean things such as 1, 2, 3, 4, and so on, okay? But not necessarily negative numbers just yet, okay? So we don't have negative numbers when talking about these whole numbers. Now, that special N off to the right, that is the symbol that we use to describe, hey, we're dealing with whole numbers. And let's go ahead and talk about the Z over there, okay? Integers. Now, this is talking about not only whole numbers, but also negative numbers. Things such as -1, maybe -2, 0, 1, 2, okay? So we also have negative numbers in this realm. Now, looking at the rational numbers, okay, that Q right there, that starts to talk about not only all those numbers, but a fraction. So something like, now the notation that a lot of people use and a lot of professors they like to say P over Q. Now what that means is any number P, any number Q that makes a fraction, that is a rational number. So for instance, things like 1/4, okay, or something as like simple as 3/4, okay, 5/4, okay? So we have these rational numbers, these fractions, okay, that make up this system. Real numbers is basically any number you've ever heard before. Anything from -100 to positive 1 to the weird number pi that we experience, or maybe you've even heard of this weird E symbol, okay, the exponential. Let me try that again. There we go. Nope, still messed that up. So basically any number you've ever experienced is the real number system. Now, there are crazy numbers such as imaginary numbers, but don't worry, we will not be discussing those anytime soon, okay? So for now, we just need to know whole numbers. We need to know about integers. We need to know about the rational numbers, those fractions, okay? Any type of fraction. And then real numbers, which is just all of them included, okay? Your fractions, your integers, your whole numbers, that's your real number system. Now, this bottom part where it says not included and included, this part, it goes on to say about how we're going to use these numbers in notation, okay? So let's talk about some different types of notation. When we say not included, some things that we should be familiar with is symbols such as less than or greater than, right? Those symbols right there said that X value is less than, okay? But on the flip side, included, we would say less than or equal to, or greater than or equal to. Okay, so those are some that we're familiar with, and some other ones we might be familiar with, probably from our Algebra 1 days, is how we use our brackets and our parentheses. If we want to say something is not included, we used parentheses, and if we wanted to say it was included, we'd use a bracket system. Look something like that. Now, also, something that we've even worked with these past couple of days is the line itself. If we had a dashed line on our graph, that told us that, hey, that is not included if we found like a coordinate point on it. But on the flip side, when it was included, it was a solid line. So we had something like that, okay, where it was included in the system. And then last but not least, maybe one that might be new to us, is if we see a circle, okay, that is not filled in on a graph, okay, and it's just chilling on the graph, that means it's not going to be included. However, if you see that circle is filled in, okay, that means it will be included, okay? So now what we're going to do at this time is we're going to take this knowledge that we just received and we're going to go ahead and demonstrate it in this table, okay? So let's go ahead and apply a little bit of what we just learned. Now, looking at this first one right here, we're going to rely on this graph over here to the right to create this inequality, this set builder notation, and this interval notation, okay? Now, let's go ahead and look at this graph and see what it's telling us. It says right here that I have a filled in circle at -4 and a filled in circle at -2, okay? So looking at these points right here for interval, okay, I'm going to say that it's a bracket because I have a included, it's filled in, okay? It's a filled in of -4 all the way to 2, okay? So that right there would be our set, not our set builder, but our interval notation. Now for our inequality, okay, we said that they are still included, so we have our -4, right, and our -2. The way we write that is we use our inequality symbols. We have less than or equal to 2, our x can be, or it's greater than 4, okay? Let me go ahead and write that a little bit better. I've got that right there. Perfect. So what this means is x, it can't go past -2, right? It has to be less than -2, or it could be equal to -2. However, what we notice is x, it could be bigger than -4, right? And so that's why our x exists between these two numbers, okay? Now, set builder notation is probably not everyone's favorite, but it does have its uses, and we need to definitely know what it's talking about. So the first thing you have to do with set builder notation is draw your little squiggle, okay? It looks kind of like a sideways W. It's kind of the best way to describe it, and that's going to be how we kind of set things up. Now, the way we write what's inside this bracket here, and see even my skills right there, not all that well, but we have x such that, and that's what this line means, okay, means such that, okay, -4, okay, or x is greater than -4 but less than -2, okay? And that's how we would write it in our set builder notation, okay? Now, like I said, this is typically not everyone's favorite. I would venture to say writing it in interval notation is what everyone prefers to write it as, but you'll see later on that set builder notation will have its place in this world. So let's keep going. So looking at the next one right here. So it says here in set builder notation that x, okay, is greater than -2. Okay, so let's actually go ahead and take this information and apply it to the graph over here, okay? So going over here to my graph, I'll go ahead and do some points. I've got 0, we'll do -1, we'll do -2, and I think that should be good. And then I guess put a 2 out here. There we go. So let's go over here. We see that it's not included, right? This greater than symbol. So we're going to go over to where -2 is and put an open circle, okay? An open circle. And let's think here. Where are all the values, okay, that are greater than -2? Well, those are numbers like -1, 0, 1, 2, right? Those numbers are greater than -2. So that means I'm drawing my line this way, okay? Those are numbers greater than -2, okay? Now, with that being said, that makes it a little bit easier to write this interval notation. Now, we just got done saying that open circle means not included, right? So we're going to be using a parentheses, okay, for our -2. Now, come to think, where is this arrow going now? How far to the right is it going? Well, when we write that arrow like that, that means it's going to infinity. Okay, it's going to be going on forever. Now, we can't control infinity, or we can't, you know, include it in our system because it's just going to keep going, right? Can't contain it. So that means we also have a parentheses for infinity, okay? For anywhere there's infinity, we're going to put our parentheses. Now, coming over here to our inequality, it is simply just like what set builder has in there. We're going to say that x, okay, is greater than -2, okay? So that's perfect. So as you can see, inequality and set builder notation have a lot of similarities, okay? And we can definitely use that to our advantage, that if you can write inequality notation, you can definitely use set builder notation, okay? Now, let's go ahead and take a look at the next one. Now, we are first now given interval, okay? And it says that this one right here is going from negative infinity to 2, and then there's this weird u here, okay? What does that u mean? Well, that u to some people, you'll see in textbooks, you'll see that they call that union, okay? That's an O, okay, union, or the phrase or, okay? Now, both have its place when writing, okay? So you need to make sure you know both, okay? That u means union or means or. Now, let's go ahead and take this interval notation and let's apply it to the graph first, okay? All right, let's take a look at this graph. So looking at this graph right here, I'm going to go ahead and put some points down. I've got 0, 1, 2, 3, 4. I've got -1, -2, and -3, okay? Now, it says that I have negative infinity to 2. So I'm going to go to my 2, and you'll notice that it has a parentheses. So that means I'm going to put an open circle, right? Because it's not to be included in this scenario. Now, it says that it goes to negative infinity, so we have our line going to negative infinity, right? And then it also says, or it can go to positive infinity. So what we see here is it has options, right? This graph can either go to negative infinity, or it can go to positive infinity. Now, this is going to help us, okay, looking at this graph, be able to write these other types of notation. So let's kind of come over here and let's take a look at this inequality, okay? So we said here that x, okay, has the ability to be greater than 2, right? Actually, let's start with less than. X has the ability to go to negative infinity, right? So x can be less than negative or positive 2. Or, okay, x can be greater than 2. So as we can see, that phrase or is going to be helpful in writing inequality notation, okay? Now this is where set builder notation shines, okay? It makes it a little bit easier to write because, and let's go ahead and draw our squiggles here, because x can be any number, right? It just can't be the number 2. It literally goes from negative infinity to positive infinity, but just cannot include the number 2. So all we have to write here for set builder notation is that x cannot equal 2. And so that's why some people prefer set builder notation, because it allows us to go ahead and key in on specific attributes of a graph, okay? And that allows the reader to say, all right, so it can be any number, just not 2. Alrighty, let's go ahead and take a look at this next one, okay? So once again, the graph over here, okay, is a little bit different, okay, a little bit more, I guess, to write down, but it says that it includes -1, okay, because it's got the filled in circle, and it goes to +1. Now, +1 is not included, right? It's got an open circle. And then you'll notice that the 2 is included, right? It's over there off to the side, a little detached, but it is off to the side, right? So what we can say here, let's start off with the -1 to +1. We can say that we're including -1, but not including +1, okay? Or, okay, we can add our union, okay? If it's not that, okay, if it's not between -1 to +1, then it's going to be the number 2, and that's all we have to write, because it's simply just including the number 2, okay? So coming over here, the way we write that for inequality, okay, is that x, okay, is going to be bigger or equal to -1 or less than +1, okay? Or if it's not in between those two numbers, is going to be the number 2, okay? Now, I know a lot of you are probably looking at this interval notation and you're probably saying, well, Mr. Farmer, you keep saying that this less than or equal to symbol is being used to say that x is bigger than -1. And the truth is, that is what we have to put there. That is the correct notation, because what we're saying is -1 is less than that value of x. Okay, that's how we try to interpret it, is that -1 is less than that value of x, because all the numbers coming back over here, all the x values are going to be bigger than -1. They're going to be larger than it. So -1 is indeed less than all this red, okay? And the red that I'm speaking about is this part right here. That's where all my x values are, okay? My x values are along this red line right here. Or, like we said with that phrase, or it's number 2, okay? So keep that in mind when looking at that notation, and don't let it confuse you too much. Now, coming back over here, we're going to go ahead and say that x, okay, is such that it's between -1, okay, or it's equal to 1, right, or less than +1, union, or it's the number 2, right, or it's the number 2. And that right there would be the set builder notation, okay? Now let's go ahead and take a look at the next set of questions. Alrighty, so now we're taking a look at number 5 through 8, okay? So since set builder notation is probably the more new topic that we've ever experienced, we're going to continue to practice it, okay? So you'll notice for number 5, I wrote this word inclusively, okay, at the end, and for number 8, I wrote exclusively at the end, okay? That word was supposed to be attached onto your paper, okay, and it's supposed to be in the notes. So go ahead and write inclusively next to where I have it, and write exclusively next to it, and you'll see how those words play a part in writing this set builder notation. Now off to the side, what I want us to go ahead and do is write this symbol that is commonly used in set builder notation, and what we're going to be using right now. This E element, okay? What this is trying to communicate is it's trying to say is an element of. Now, what the word element is trying to refer to is the x value, okay? Whatever x is in the set builder notation, okay? Now, coming over here, we go ahead and read the first one. It says the set of all natural numbers between 8 and 730 inclusively, okay? Now that word inclusively is important because it helps us understand that we're going to be including those numbers, 8 and 730. So you'll notice here that we'll put x just like we always have, but now we're going to introduce the e, okay, this time, okay? We're going to put our e in there. Now, we said the set of all natural numbers. So up at the top of our paper, remember what that natural number was, okay? It's right up here, okay? Or it says the numeral numbers, also known as the whole numbers. We're going to go ahead and write that symbol in our set builder notation, okay? And so we have something like that, right? And then we put our line here, okay? Our such that symbol. And we say 8, okay? Inclusively, okay, less than or equal to the x value is less than or equal to 730. And then we write a little squiggle, okay? And so we use the inequalities to describe that, hey, our x value is between 8 and 730, and we're including them, okay? The x is inclusive, okay? So that's why we put the line underneath it. Now let's take a look at the next one. Okay, the set of all integers except 50, okay? And this one will be kind of nice. So we're talking about integers, right? So we say x is an element of the integers. Now, if you want to, you can kind of look on your paper what the integer symbol is. It looks something like that. And it says such that, and when we say that, it's all the numbers. So it's basically all real numbers, but x cannot equal what? 50. And so we can write something as simple as that to communicate, hey, you can do any number, just not 50. Now let's take a look at number 7. It says the set of all real numbers. Okay, so let's start there. So we have x is an element of the all real numbers. Okay, so remember what that symbol is? That symbol is your little r. Okay, such that, okay, greater than 19 but less than 32. So our x is between 19 and 32. Okay. We know that x is going to be bigger than 19, but less than 32. And you'll notice here that we're not including them, right? It doesn't say that it's greater than 19 and 32 inclusively. It just says, hey, x is going to be bigger than 19, but x is also going to be less than 32. So that is why we only have our greater than and less than symbol, or I mean our less than symbols, okay? Now looking at number 8, we see that it goes on to mention that 7 and 10 are exclusive, okay? And we're talking about the set of all whole numbers, okay? So I've got x is an element of all the whole numbers, so we've got our n. And then we have between numbers 7 and 8. Well, the numbers between 7 and 8 are 8 and 9, okay? So that is how we would do the last and final one. And this is very similar to number 4, okay? If you look at number 4, it went and said that 2, okay, is included. And the way we wrote it in our set builder notation is we had -1 is less than or equal to x, or less than 1 or 2. Okay, and that's kind of how we did number 8. 8 and number 4 are very similar. Now let's go ahead and take a look at number 9, 10, and 11. Alrighty, so this is going to draw on more of our knowledge of how we go ahead and do domain and range. And we're going to go ahead and refresh ourselves on how we would use it with the symbols, okay, we just learned about. So looking at this first graph right here, let's go ahead and zoom on in. Let's talk about its domain. Now, when we talk about domain, okay, we're talking about the number to the far left, the furthest number left, and the furthest number right in terms of x, okay? So looking at this right here, the furthest number to the left, okay, x-wise, is -3, right? Because that's where that line is. And then the furthest number to the right in terms of x is 2, okay? So what we see here is that it doesn't have any other x values except -3 and 2. So the way we would go ahead and write that up top is we're going to go ahead and say -3. Oh, my pencil, there we go. -3 union 2, okay? Because it's either -3 or it's 2, okay? It's not any other x value. Now the range, which you'll notice, okay, we look for the number that is the furthest one on the bottom for the y values and the furthest one to the top, okay? So looking here, though, this arrow is kind of showing me that it's going on forever down, and then this arrow is showing me that it's going on forever up. And you'll notice there's no gap in between them, okay? It says that it's, you know, if it's not going down, it's going to continue to go up. So that means this graph right here, okay, is going to -infinity, okay, to +infinity. Now, I see a lot of people get very lax on writing this, but you have to make sure you either put brackets or parentheses around this, okay? Now, you can't quite include infinity, right? So we have to put parentheses around them, okay? Make sure you put those parentheses. They're very important. Now, let's go ahead and write the domain and range in set builder notation. So the way we'd say it is for the x values are such that they are it's either -3 or it's going to be 2. Okay? Now, the range itself, you'll notice, goes from -infinity to +infinity. So y is all real numbers. So we could say that y is such that y is an element of all real numbers, okay? It can be any number. Now, let's go ahead and see whether or not this thing is a function. Now, something that you may have learned in past days is that it has to follow the vertical line test. So we have to see, is this graph, if I were to draw a vertical line, does it touch the graph more than once? And you'll notice right here, it touches the graph multiple times. So we would end up saying no, it is not a function. Let's go and take a look at this one. This one right here. the domain will look for the farthest number to the left and the farthest number to the right in terms of x, okay? So you'll notice here it goes to -5 to +5, okay? And since the open circle for the -5, we're going to put a parentheses around him because he's not included, but +5 is because it's got a filled in circle. Now the range is the topmost or the bottommost y and the topmost y. So let's go ahead and take a look. It looks like the furthest down it goes is right here, and the furthest up it goes is up here. Now, I know that when looking at this, you'll be asking, hey, I see that the y value has both a open circle and a closed circle involved. Well, if there's at least one closed circle, we're going to go ahead and say that we include that value. Okay, if there's at least one closed in circle, we're going to include that value. So we're going to say we're going to include -2 and include +2. Okay, because we have a filled in line right there because we have to include those values. Now, looking at the domain and set builder notation, let's go ahead and do that. We have x is such that x will be larger than 5, okay, but we're not including it, or less than or equal to +5. And then for the range, we have y is such that we're going to include -2 and and then we have it's less than or equal to +2. And now let's go ahead and see if it passes the vertical line test. So we draw some lines, and you'll notice these lines themselves do not cross the graph twice. So we'd say yes, this is indeed a function. Okay, so let's come over to here to this next one. Talk about the domain here. Now this one has some arrows showing us that it's going to continue to grow, both in the y direction, okay, and in the x direction. Even though it shows those arrows going up, those arrows are going up and slightly to the left and to the right. So that means they're going to continue on forever. So that means my domain is from -infinity to +infinity. Now, of course, we can't include that, so we put parentheses. Now, in terms of y, the furthest down that this thing goes is at 0. But you'll notice it goes up to infinity on both. So we're going to go ahead and say that the range is from 0, including it, to infinity. Now we're going to say we can't include infinity. Now let's go ahead and take a look at this domain and set builder notation. Let me try that again. So we have x is an element such that x is an element of the real number system, because x can be any value, right? Because it's going up and to the left to infinity and up and to the right into infinity. So it can be any of those x values, okay? So then for the range, though, we're going to say that y is such that y is greater than or equal to 0, right? It has to be greater than that 0 value, okay? It never dips below. And then if we go ahead and look and see if it crosses the vertical line test, does it hit more than once? And we would say, no, it doesn't. So it's yes, it is a function. So guys, that is the first set of online notes. Make sure you guys have this ready and written down. And just so that way everybody can see a last picture one last time, this right here is what we should have written down. Alrighty, guys. See you in class on Monday. Alrighty. Bye-bye.